Bismillah ar-Rahman ar-Rahim. Inshallah, we'll continue doing 4.3. We did the first part, which is discussing when the function is increasing or decreasing using this test. Now we'll talk about how to check when the function has a relative local maximum or local minimum using the first derivative test. If I have increasing, then decreasing, then I have local maximum. Decreasing, then increasing, I have local minimum. If there is no change, it means we have neither local maximum nor local minimum. So what's the idea? I need to find the function, the seeds in the domain of f with critical numbers mainly. If prime equals 0, if prime does not exist. Also, sometimes I need the points of discontinuity. We have the real number, real line. And then we determine the sign of f prime. If it is positive, then negative, then we have local maximum. If it is negative, then positive, then we have local minimum, and so on. Okay. We have this function in this interval. Okay, so we need to find first f prime, critical number. F prime is what? Half minus cosine x. And this is always defined, so we have not equal to 0. So it means cosine x equal half. When cosine x equal half, it's pi over 3, and it's in the first and fourth quadrant, so it will be pi over 3 and 5 pi over 3. Yeah. So it's the first and the fourth quadrant. Then I have the real number line. I have 0, 2 pi, and I have pi over 3 and 5 pi over 3. Okay, between 0 and don't forget this is f prime, will be half minus cosine x. Okay, so we take a value between 0 and pi over 3. Take pi over 4. So you have half minus square root 2 over 2. That will be negative. Here I take like pi over 2. Cosine is 0. So I have positive. Then we have, will be like 7 pi over 4. It will be square root 2 over 2. So this is a negative. So decreasing, increasing, then decreasing. So I have here a local minimum. And here I have local maximum. Okay. Another example, which I think easier. F prime, since it's just a polynomial, just need to do calculation. I have 6x squared plus 6x minus 72. I have 6 as a common factor. So I have x squared plus x minus 12. So that will be 6x plus 4 times x minus 3, 4x minus 3x. This will be x. Yeah. Equal to 0. So I have critical numbers. X equal minus 4 and x equal 3. By the way, the domain of the function is R. So I have this minus 4 and 3. Take a value less than minus 4, negative, negative, so that will be positive. 0, make it negative, that's positive. So increasing, decreasing, increasing. So I have a local maximum at x equal minus 4 and local minimum at x equal 3. Yeah. Another function, just when he says the relative extrema, he's talking about both relative maximum, relative minimum. What's the domain of the function? Or real numbers. So I have f prime, that will be 2 over 3, x squared minus 4 to the power minus 1 over 3. Yeah, times 2x. Okay, so that gives me 4x over 3 cube root x squared minus 4. Yeah, 2 over 3 minus 1 is minus 1 over 3. Okay, so critical numbers, x equals 0, and x squared minus 4 equal to 0, which means x equal plus or minus 2. So I have this is the real number line. I have minus 2, 0, and 2. Okay. So I want to check the sign for this function, f prime. Okay. If it a value less than minus 2, when we examine minus 3, that gives me negative over positive. That will be negative. Take minus 1, will be negative over negative. That will be positive. Take 1, positive over negative. That's negative, and this is positive. Take 3, it will be positive over positive. So it's decreasing, increasing, decreasing, increasing. So I have here local minimum, and here I have a local maximum, and here I have local minimum. What we care about is the domain is all real numbers. So these values are defined at the original function. At f prime, yeah, this is just to find the critical numbers. Okay. Find the relative extent of this function. Okay, now be careful. What's the domain of f? All real numbers except 0. And what is the function? The function is x squared plus x minus 2. That will be the function if I distribute it. I will rewrite it in a different way. So it will be f prime, easy to find f prime now. It will be 2x minus 2x minus 3. So I take 2x minus 3 as a common factor. What is the remaining? The remaining is x to the power 4, yeah, minus 1. Yeah, which is, I can rewrite it as 2 x to the power 4 minus 1 over x cubed. Now, I have point of discontinuity from here, which is x equals 0. This is point of discontinuity. Okay, now I have f prime equals 0. So I have x to the power 4 minus 1, which is x squared minus 1 times x squared plus 1 equals 0. So I have x equal plus or minus 1. This will not give me any real zeros. I have only x equal plus or minus 1. So these are the critical numbers. X equals 0 is not a critical number because it's not part of the domain of the function. Okay, now I plug the numbers. I have minus 1, 0. The function is undefined, and this is 1. Okay. Now I need to check the sign. Before minus 1, take minus 2. That will be positive or negative. That is negative. Minus 1 and 0, take minus half, for example. The numerator will be negative. Negative, that is positive. 0 and 1, take half. Negative or positive. Negative 1, I have positive. Okay, so it's decreasing, increasing, decreasing, increasing. Don't forget, the function is undefined at 0. So we cannot have local extrema at this value 0. So I have local minimum here, and I have local minimum here, and I have local minimum here also. At 0, the function is undefined, so I have nothing. So how many? So you have local minimum at x equal minus 1 and at x equal 1. Nothing at 0. So you have two relative extreme. Good question. Okay. Now we'll have all the exams questions. Just to finish the section, local maximum of this occurs at, so I need the x values. So I have f prime, for example, the domain of f is R. So I have f prime will be 5x to the power 4 minus 5 Yeah, make it equal to 0. Same thing, I have 5x to the power 4 minus 1, 5x squared minus 1 times x squared plus 1. So what we care about it is minus 1 and 1. From this one I have no real zeros. Okay. So take a value. I have this is my function. To minus 1, 1. Take a value between before minus 1, like minus 2, that will be positive. 0, negative, more than, that will be positive. So I have increasing, decreasing, increasing. So I have local maximum here. And here I have local minimum. I don't care about this. I care only about the local maximum. So at x equal minus 1. The function, he gave you different answers. Okay, so let us do the calculation. F prime, the domain is all real number. No? The domain is all real number, so easy. 3x squared plus 4x plus 1. I need to simplify it. I need minus 1 over 3. Huh? Yeah, it seems to be 3x, x, yeah, plus 1 plus 1. Yeah, that gives me 1, x plus 3, 4x, yeah, equal to 0. So I have minus 1 and minus 1 over 3. Yeah, applied to this function. Okay, minus 2, that will be negative, negative, that is positive. This is positive, the same thing, if x equals 0. And here I have negative, like minus 2 over 3. Give me what? Negative, and the other one is positive, so the answer is negative. So I have increasing, decreasing, increasing. So I have local maximum here, and local minimum there. Yeah, so local maximum at x equal minus 1, correct. Local minimum at x equal minus 3. So this is the correct answer. The number of relative extreme of this function, let us do the calculation. The domain of f is all real numbers. Look, we have different way of setting the function. Just say local maximum equal to what, or local minimum. The function has, and he give you both. Or he said the number of relative extreme. Yeah. Now I have f prime will be what? Minus 15 x to the power 4 plus 15x squared. So f prime, I take minus 15x squared. Yeah, what's the remaining? The remaining is x squared minus 1. Am I right? Yeah, it's minus 15x to the power 4 plus 15x squared. Correct. So f prime equals 0. That gives me x equals 0, and x equal minus 1, and x equal 1. So we have minus 1, 0, 1. Take a value before minus 1, like minus 2. That will be negative. Times body, that will be negative. Minus 1 and 0, take minus half. That will be negative. Positive, negative, that will be positive. By the way, this is always positive, so it will not make a difference. Half, it will be, no. Yeah, minus half will be negative, yeah, it will be positive. Half will be the same, negative times negative, that will be positive again. More than 1, 2, it will be negative. So we have a relative extrema. At x equal minus 1 and at x equal 1. We don't have it as 0 since there is no change. Huh? None here. We have 1 here, 1 there. So the number is 2. And we have, this is the local minimum just for information. And this is the local maximum. This is the minimum. So we have 2. Okay. Another way to state the problem, the function has its maximum this, find x actually. Do the calculation. The domain is all real numbers. So it is f prime, product of two functions, derivative of the first times the second, plus the first, derivative of the second is 1, so no need to worry about. I can take x minus 1 common factor. I have 2x plus 6 plus x minus 1. So I have x minus 1 times 3x plus 5. That will be f prime. F prime equals 0. So I have x equal minus 5 over 3 and x equal 1. Plug them there. Minus 5 over 3 and 1. This is my function. Take a value like minus 2. It will be negative. Negative, that is positive. Take a 0. It will be negative. Take 2. It will be positive. So if increasing, decreasing, increasing, he wants what? Maximum. Maximum occurs at minus 5 over 3. Equal minus 5 over 3. The number x at which the function has a relative minimum, maximum, minimum, okay. What's the domain? Or a number except 0. So what is f prime? It's 2 minus 1 over x squared. In other words, it's 2x squared minus 1 over x squared. Yeah, so I have f prime equal 0. So I have x equal plus or minus 1 over root 2. Okay, so I have minus 1 over root 2. And the 0 as point of discontinuity. And 1 over root 2. Okay, take a value here, minus 2. That will be positive, that will be positive. Minus 1 over root 2. I take, for example, minus 1 over 2 minus half. It will be negative. 2 over 4 minus 1, that will be negative. And with the 0, the same thing. Take 1 over 2. It will be negative. This is always positive. Take a value more than this, like 2. It will be positive or positive. That will be positive. So positive, increasing, decreasing, decreasing, increasing. He wants what? The minimum will be here. That will be the minimum. So 1 over root 2. If the function has a relative maximum, then a equal this. Yeah, the same problem. Yeah, it is the same problem, is it? Yeah, exactly the same function, but you want the maximum. The maximum will be here. So the local maximum at minus 1 over root 2 times root 2 over root 2. That will be minus root 2 over 2, which is this one. So this is the answer. Now we'll go to the next one. The local minimum occurs at which function? So we'll check the function. The domain of the function is what? I need x to be greater than or equal to 0, so from 0 to infinity. So what we care about is this interval, from 0 to infinity. Okay, let us find, or maybe you can write the function as a power. It will be easy to do the calculation. So it will be f prime. It will be half. X is minus half. Minus 1 over 4. X is minus 3 over 4. Yeah, and it's the common factor 1 over 4. X is minus 3 over 4. This one will be what? X to the power 1 over 4. 1 over 4 minus 3 over 4 is minus 2 over 4, which is this. So that's correct. Minus 1. So I have what? Fourth root of x minus 1 over 4, x to the power 3 over 4. Yeah. So critical numbers, f prime equals 0. Yeah, sorry, this is 2, huh? Yeah, 2 times 1 over 4 is half, so I need 2. There is 2 missing. So I have 2 root minus 1 is equal to 0. So fourth root of x equal half. So it means x equal 1 over 16. And the 0 here. The 0 is just the border, so no need to think about it. This is 0, and I have 1 over 16. Yeah, and this is my f prime of x. So I have to check the numbers. And to take a value here. Let me take a value like test value 1 over 81, but the fourth root of this is 1 over 3. So I have 2 over 3 minus 1, that will be negative. over positive, so that will be negative. Take more than this, take 1, it will be positive, move positive, that will be positive. So you have decreasing, increasing. So you have a local minimum at x equal 1 over 16. Be careful that he wants the local minimum. He doesn't want it will be at what value. He wants it exactly. So we need to find the y value. It will be a square root of 1 over 16 minus the fourth root is 1 over 16. So it will be 1 over 4 minus half, which is minus 1 over 4. Yeah. Yeah, I think I'll stop. I'll stop the recording. Yeah, I wouldn't like to have long videos. So let me stop the recording. Thank you.